This is the Leaving Cert Ordinary Level Mathematics DEBmock from 2020, Paper 1, and this is question 1. This question is involving sequences, an arithmetic sequence. It explains that in the question. And what we have is a series of money that month on month increases the amount that they are saving. So in the first month it's 120, in the second month it's 130, so moving on a further 10 euros. In the third month, in the fourth month it's 150, and then on from that the fifth month would be 160, the sixth month would be 170, and then it would be a case of carrying on that process of working out how much would be in the 12th month. So the 7th month would be 180, the 8th month would be 190, the 9th month would be 200, 10th month, 11th month, and then finally the 12th month. So go through that again. That was the 7th, 8th, 9th, 10th, 11th. Then asks us to find the amount of money they would save over 18 months. So you could sit there and go, 120 plus 130 plus 140 plus 150, and carry on doing that as a process. 120 at 130 at 140, all the way up to whatever they have in the 18th month. Okay, and you have to work that out. But just work your way through 18 values. An alternative to that would be to use the formula that's given for the sum of an arithmetic sequence. It's given to you in the formula book. All you need to know is the number of values. In this case it would be 18. The first value, which in this case is 120, and the common difference. Remember, an arithmetic sequence is all about having a common difference, which in this case would be 10. So the sum of the first 18 terms would be 18 divided by 2, multiplied by 2 lots of the first term, plus 1 less than the number of terms in the sequence being added together, multiplied by the common difference. And if we work that out, and we just use a calculator for this as a process, we end up with, in terms of set of money, it is 3,690. So that as a process is worth 15 marks in total, 5 for the first part and 10 for the second part. The third part of the question is, again, a slightly different look on the same idea of an arithmetic sequence. In this case, they're talking about, we're going to actually go on holiday once they've saved 4,300. So they want to know, when are they going to have saved 4,300? So what we want to know is what will be the sum of values that will get me a total sum of 4,300. Now, we know it's going to be more than 3,690, so it's going to be more than 18, but how many more? How many months in total? So we could, one option is to use that same formula again, but in this instance we don't know what n is. So we have to solve that equation for n. So we end up with 120n plus 5n squared minus 5n is equal to 3,690. All I did there was I just basically multiplied out the brackets. So that's n over 2 multiplied by 2 lots of 120. That is, and then it's n over 2 multiplied by 10n, and n over 2 multiplied by minus 10. We end up with a quadratic equation And if we were to solve that quadratic, either by factorizing or by using the minus b formula, we would get two values of n. I'm not going to go through the process of solving a quadratic. You should know how to do that. We get two options. We get n being 20 or n being minus 43. Now you can't have a negative value of n, so we would reject that, and so effectively the answer of 20. And that would be fair because it's more than 18, okay, which is what we said, it would be more than 18 months, and the answer is 20. Seems like a reasonable answer. That was 5 marks available for that question. And then lastly, over the page, we had a final part. As part of their visa requirements, Tom and Anne must have savings of 5,000 Australian dollars per person. They intend to borrow the remainder of the money required from their parents. Given that the exchange rate is €1 is equal to 1.61 Australian dollars, how much do they intend to borrow? Give your answer correct to the nearest euro. So if it's per person is 5,000, then we are looking at having two lots of 5,000, which is 10,000 Australian dollars. So then we have to say to ourselves, right, hey, what would that be in euros? So how many lots of 161 are there in 10,000? So the number of euros will be 10,000 divided by 1.61. That gives us 6,211 and 18 cents, correct to 2 decimal places. Because it turns out that's what money is. Money is always going to put to 2 decimal places. And we find that we need 6,211 euros and 18 cents. Now, they've already saved 4,300. That's part of the previous question. So how much extra are they needing? Well, it's the difference between that 6,211 and 18 cents and the amount of money that they were going to save, which is 4,300. And we get to the nearest euro 1,911 for 5 marks.